So first, explain oxidation and reduction reactions. So the key word to remember with these is actually an acronym, OIL-RIG. And this stands for oil, oxidation is loss of electrons, and RIG, reduction is gain of electrons. So keep that in mind the whole time we're talking about redox reactions. So oxidation and reduction reactions, often called redox reactions, are types of chemical reactions that involve the movement of electrons between two reactants or two species. Chemical reactions in our cells are, by definition, the rearrangement of the molecular or ionic structure of a substance. So if you remember from a previous objective on chemical bonds, we know that bonds involve electrons. And when electrons are shared or transferred between atoms, there's a bond there. So when there's movement of electrons across bonds, that is called a redox reaction. And remember, electrons have a negative charge. So when we say RIG, reduction is gain of electrons, that means the electrons are going to an atom and that atom becomes more negative. And oil, oxidation is loss of electrons. That means that the atom losing the electrons becomes more positive because the negative electrons are being lost. And how do we know when or where the electrons go in a chemical reaction? Electrons will go to the more electronegative atom. Remember, electronegative means an atom's strength or ability to attract electrons or to hog electrons, you might say. So let's look at some examples of this. So here's an example that's hopefully pretty tangible to most of you, something you've seen before, rusty nails. When a nail, which has iron in it, is exposed to the elements like air and water, over time it becomes rusty. So what is going on a molecular level here in terms of oxidation and reduction? So nails are made of iron, which is a metal. And we know that metals are not electronegative elements. They don't really attract electrons. They tend to give them up. Oxygen in the environment, in the air and in water, is very electronegative. And so it will attract electrons. So when oxygen in the environment combines with the iron in the nail, we know that the electronegative oxygen can cause the electrons to shift. So the iron in the nail will lose its electrons and the oxygen in the air or water will gain electrons. And this forms a new compound on the nail called iron oxide, aka rust. And a redox reaction occurred. So the iron right here, this chemical symbol for iron is Fe, lost electrons. So it was oxidized, and the oxygen, here's the chemical symbol for oxygen, O2, it was reduced, so it gained electrons. And let's see if we can give a little bit more of clarification on what's going on in a chemical reaction like this. We're going to do one more example. So this example may be a little more abstract, and it is a chemical reaction between hydrogen gas and oxygen gas. So fun fact, this is a reaction that happened in the Hindenburg Explosion, if you're familiar with that. The Hindenburg was a big blimp filled with hydrogen gas to make it float and could transport people through the air. But the problem with Hindenburg was that when hydrogen gas is in the presence of oxygen in the air, and then if there's a spark, a little bit of energy added to the system, then an explosion happens. And that's what happened. So let's talk about what happened in this chemical reaction at a molecular level. So what is getting oxidized and what is getting reduced in this reaction? So on the, move my notes over. On the left side of the equation, there are two hydrogen atoms in this molecule, this hydrogen gas. So as you can see, these two hydrogens look the exact same. This is there's no difference in electronegativity across these two hydrogens. So this is a nonpolar covalent bond. So there's no hogging of electrons going on between these two H's. And same with this oxygen molecule. It's the same on both sides, oxygen, oxygen, these are identical. So equal sharing of electrons, no hogging of electrons. Then you move to the right side of this equation, and you have H2O. And we know that there is a difference in electronegativity in between these two atoms, the hydrogen and the oxygen. So oxygen, again, is much more electronegative than hydrogen. So oxygen is hogging the electrons. And you could say that it gained the electrons. So gained electrons, rig, reduction, oxygen was reduced. And I put this partial negative symbol here to remember that the negative electrons are being hogged by the oxygen. And hydrogen, which is not electronegative, is not hogging the electrons. The electrons are not really hanging out around the hydrogen. So you can say that hydrogen is losing the electrons. So loss, oil, H, hydrogen was oxidized.